Let's move to the next question. In this question, we are given three vertices of a parallelogram ABCD and their coordinates are 3, -4, -1, -3 and -6, 2, and we have to find out the coordinates of vertex D and we have to find out the area of the parallelogram ABCD. Let's work out the problem. Here the vertices of parallelogram are A 3, -4, B -1, -3 and C -6, 2, and we assume D with coordinates x, y be the vertex. We have to consider a parallelogram. Let it be ABCD and the diagonals intersect at point E. One of the way to get the solution is to find the value of vertex D. One of the way to find the solution is to use the property of parallelogram. What is its property? In a parallelogram, diagonal bisects each other. That means one of the diagonal passes through the midpoint of the other diagonal. So here E is the midpoint of diagonal PD and diagonal AC. Therefore, E is the midpoint of AC and it is equal to midpoint of BD. We know that the midpoint of any 2 points is the sum of x coordinates divided by 2, sum of y coordinates divided by 2. Here we take A and C. Their x coordinates are 3 and -6. So 3 plus -6 divided by 2, their y coordinates are -4 and 2. -4 plus 2 divided by 2, its y coordinate. Similarly, E is also the midpoint of diagonal BD. So we have B and D. Its sum of x coordinates is -1 plus x divided by 2 and its y coordinate is -3 plus y divided by 2. Let's equate their values. Before doing that, we simplify here. 3 plus of -6 is -3 upon 2. -4 plus 2 is -2 divided by 2. It is equal to -1. -1 plus x upon 2 and -3 plus y upon 2. To find the value of x and y, we equate their respective ordered pairs. That means x coordinate is equal to x coordinate on right hand side and y coordinate is equal to y coordinate on right hand side. Both denominators 2 get cancelled. We remain with -3 is equal to -1 plus x. On transposing -1 to left hand side, we get -3 plus 1. It is equal to -2. Similarly, we solve it here. -2 times 1 is -2 and -3 plus y on right hand side. Therefore, y is equal to 3 minus 2, which is 1. Vertex D is -2, 1. Therefore, we get the vertex D -2, 1. And here we have to find the area of this parallelogram. How we can find out the area of this parallelogram? Area of this parallelogram, the product of base into height. And area of parallelogram in terms of diagonal is the half of product of length of diagonals, that is BD times AC. So to find its area, we have to find the distances AC and BD. AC is equal to under root sum of difference between x coordinates and difference between y coordinates, that is 3 minus of -6. Here we should be careful while we are dealing with negative signs, and difference between y coordinates is 2 minus of -4 whole square, and it should be in square root. So 3 minus of -6 is +6, so 3 plus 6 is 9 and 9 square. 2 plus of -4 is +4, 2 plus 4 is 6. 9 square is 81 plus 36 and it is equal to under root 117. Similarly, length of diagonal BD is under root -1 minus of -2 whole square plus -3 minus of -1 whole square. since its x coordinates are -1 and -2 and its y coordinates are -3 and 1. By simplifying we get minus of -2 is +2, so +2 minus 1 is 1 whole square and -4 whole square. It is equal to 1 plus 8, 1 plus 16, it is equal to √17. Therefore, area of parallelogram ABCD is equal to half of √117 times √117. It is equal to √2009 upon 2. Since the area is in square units, so we have here square units. Therefore, area is √2009 upon 2 square units.